Hello, welcome to this channel, Class 12 Mathematics NCERT Solutions, Continuity and Differentiability. Exercise 5.1, Questions 4 and 5. I'll go into the question. Prove that the function f of x is equal to x power n is continuous at x equals to n, where n is a positive integer. Obviously it is continuous because it is polynomial, therefore it is continuous. So we'll see the solution now. F of x is equal to x power n is given, where n is a positive integer, which is a polynomial whose domain is R. Also we know that every polynomial function of x is continuous function in its domain. Therefore it is continuous at x equals to n also. We'll see the elaborate answer. Limit x tends to n, f of x is equal to limit x tends to n, f of x is x power n. So put n in place of x, you will get n power n. Again f of n is equal to n power n. Here f of x is equal to x power n. No, in place of x you put n. So f of n is equal to n power n. Since limit x tends to n, f of x is equal to f of n, we can say f of x is continuous at x equal to n. We'll go to question number 5. Is the function f defined by f of x is equal to x less than or equal to 1, equal to 5, x greater than 1, continuous at x equals to 0, at x equals to 1, at x equals to 2. We'll see the solution. Here the function is defined at all points on the real line. You see x is less than or equal to 1, function is defined. Greater than 1 also the function is defined. Now you see this function is what is known as a piecewise function, or we can even say piecewise defined function. Okay, see here. The function is defined differently in different domain. For x less than or equal to 1, the function is defined as x. For x greater than 1, the function is defined as 5. F of x is equal to 5 if x is greater than 1. Such a function is known as piecewise function. See here, for x less than 1, f of x is equal to x, continuous. For x greater than 1, f of x is equal to 5, continuous. At x is equal to 1, the function is defined differently. So that we will have to very carefully check. Do you understand that? Now at x equal to 0, because you are asked to verify, or is the function f defined by, is the function continuous at x equals to 0 is a question. So at x equals to 0, that means we will have to consider this part of the function. X is equal, f of x is equal to x if x is less than or equal to 1. At x equals to 0, you have to take f of x is equal to x. F of x is equal to x. So you want to find out whether the function is continuous at x equals to 0. Therefore f of 0 you have to find out. F of 0 is equal to 0 because f of x is equal to x. F of 0, in place of x you put 0, you will get f of 0 is equal to 0. Also limit x tends to 0, f of x is equal to limit x tends to 0, in place of f of x you put x. So limit x tends to 0, x is equal to 0 because in place of x you put 0. So what is the thing which we found out? F of 0 is equal to limit x tends to 0, x. Limit value is equal to function value at x equals to 0. Therefore the function is continuous at x equals to 0. Okay, there is no problem with this part. X is equal to 0, the function is continuous. Now we will check at x equals to 1. At x equal to 1, we will have to find left hand limit and right hand limit, because the function seems to have a breakup here, because less than 1 it is x, greater than 1 it is 5. So to the left of x is equal to 1 it is x, to the right of x is equal to 1 it is 5. So please check whether the function is continuous at x equal to 1. So you have to find in that case left hand limit as well as the right hand limit. So left hand limit of f at x equal to 1 is limit x tends to 1 minus f of x is equal to limit x tends to 1 minus f of x is equal to x, because you are approaching 1 from the left, so you will have to take f of x as x, right? Substitute 1 in place of x, so it is 1. Now you go to right hand limit. Right hand limit of f at x is equal to 1 is limit x tends to 1 plus f of x is equal to limit x tends to 1 plus 5, which is 5, because you are approaching 1 from the right, so you will have to take f of x is equal to 5. So f of x is equal to 5. That means the limit also is equal to 5. right? And see here, since the left hand and right hand limits of f at x equal to 1 do not coincide, f is not continuous at x equals to 1. Got the point? We'll go to the next case at x equals to 2. See, f of 2 is equal to 5. Also here, f of 2 means greater than 1, so f of x is equal to 5. So f of 2 is also 5. So limit x tends to 2, f of x is equal to, limit x tends to 2, 5 is equal to 5. Because you'll have to consider f of x as 5. Here what happens? Limit x tends to 2, f of x is equal to f of 2. So what is the conclusion? The function is continuous at x equals to 2. Now we will see the graph of the function. This is the function which is given in the question. You see, for x less than or equal to 1, f of x is equal to x, this much, which is continuous. Then for x greater than 1, f of x is equal to 5. Here less than or equal to 1, so the circle is shaded. Here the circle is not shaded, empty circle. So this side the function is continuous, this side the function is continuous. At x equal to 1, the function is not continuous. Is it clear? Like and subscribe. Thank you. Thank you once again.